Hi guys, welcome back to the second section of chapter 8 of part 2, right? So pointer arithmetic and how it works, right? Pointers um, can be can deal with some arithmetic functions, right? So you can add or subtract from pointers and obtain different addresses, right? So pointers can also be compared using some relational operators, equals or not equals, and some other operators, right? So in in a in a particular array, right, a integer num of 100 and uh, a pointer, right, star and point, right, uh, can be can be can be accessed like a point, like an array itself, right? uh, Essentially by pointing the pointer or equaling the pointer to the address of the first element of the array, right? Then essentially the array or the pointer becomes the array, right? So in this sense, right, an array is by default is actually a pointer, right? So continuation. So if we add the pointer with 4, right, you're basically accessing the fourth element here, right, of the pointer, right? Sorry, we're accessing the okay, the fourth element, right? 4 bytes later, sorry, right? So here's examples is that if we are accessing a num0, here's the address, and we add it by 4, we are adding it basically the we are adding all up to the fourth element, and we'll get the address of after the fourth element because it's adding uh, four elements with the size of the byte there, right? Okay, so now here's some things when we are trying to initialize pointers, and there's some tricks to it, right? For example, if we have a integer type pointer that points to the address miles, right? Now this statement is only valid if miles have already been initialized. Remember, it's not a variable, right? It is a pointer to a variable. So if we have not defined the variable, initialized the variable, then we cannot point it there, right? Or initialize it first, right? So if we are trying to say in num pointer equals to the address of miles, this would basically cause an error when miles have not been uh, initialized, right? So we have to initialize the array, right? um, um, the same thing. um, if we want to assign double to zinc, then we have declared the array as a double precision array first, right? For example, right? So passing address to a function using reference variable was declared in the previous chapter, chapter 6, right? It did imply the use of address because the reference does not provide a function with an address, particularly so and when we have the swap function, uh, you know it does not tell whether the parameter are passed by value or by reference, right? And in this case we have to look at the prototype or header line to determine this, right? So let's look at here, right? If so, when we're passing parameter, usually we passing it by value, right? And if we want to pass it by reference, that means we're passing the address to the function, right? If we're doing this, then in the function itself we need to have the ampersand here, in front of the variable being passed, thereby telling the particular function that we are dealing with a, a reference address and not a pass-by value here, right? So we don't make copies of the variable, right? We are accessing directly to the memory locations that is being dealing with or the variable being passed to the function, right? So here's an example. When we give when we use a swap function, for example, we are giving the address of a particular value as the first number and the address of the second value of the second number, right? So by doing this, we can basically swap two memory locations um, uh, uh, in that function, right? Because remember, if we're swapping, we have to know the location of the address. If we pass it by value, it will make a copy of that particular values, and when we swap those copies, we won't be swapping the original ones, right? So okay, so here for example, we define a swap function, double star double star. This is the function prototype, and when we call swap ampersand first number and ampersand second number, what we're doing is actually we're giving not the values of 20.5 but the address of the first num and the address of the second num, right, where these values are stored. And the swap function can basically receive this as a pointer, right, and then try to swap these values, right? um, right, so in this example it just prints out the addresses but doesn't swap it yet, right? Okay, so here is an example. When array is passed to a function, address of the first location is the only item passed, right? And so let's look at this one. We have the declaration insta insta. This is the find maximum, right? So when we pass it, right, so this is the number of elements and the array itself, right? So value is equals to ampersand num0, so value maximum is equals to value 0 here. Okay, so when we pass a array to a function, we are actually passing the address of num0, right, and that sits in the particular element that we are dealing with here, right? So that's the weird part about C++ here, is that when we are using variables, right, when we are using variables, we are passing it by value, but when we are using arrays, we are actually passing it by some form of a reference here, right? As it shows here that, you know, we have an array defined and we are passing the array by actually some kind of address, right? Or that's actually how it is, right? So whatever that changes into value actually changes in the array in some sense. So basically, you know, when we pass an array to this function, this array vals actually is a address of the array num, right? Okay, so another suitable header line for find max is we can have star vals, right? So notice the difference. One is an integer vals of a particular bracket, right? Or we can just set the star value to define the address of the first array, right, being passed, right? So now other pointer notations, if we are dealing with a multi-dimensional arrays, it gets a bit more complex. And basically what you want to do is have the address. Here we have the address of num00. This should be the first num, and this would be the address of num10, right? This would be the second row, right? And the first column here, right? Now, so if we two-dimensional arrays, pointers constantly allows for accessing array elements in several ways, right? We can have the address of the first element in the first row, right? And we can have the address of the first element in the second row, right? And we can access them this way, right? So each element can be accessed by applying some kind of an offset to the correct pointers, right? So for example, pointer notation here, if we want to access num0, will be star num star of this star num, right? Which would allow you to have the value num0, right? Or we want to have the second element or first third element here. Or notice the notation changes if we want to move it to the different row. So num plus 1, the pointer, the address, right? And it gets a bit confusing, especially if you know, and taking time to get used to the notation here, right? Okay, so some of the common programming errors is attempting to explicitly store an address in a variable that has not been declared as a pointer, or using a pointer to access a non-existent array or element, right? So we have a, we remember we are referencing a particular address. We can definitely do some addition or some arithmetic on it, and this may result in a particular memory location that is that is out of the array bounds, right? So this might cause an error, right? The other thing is incorrectly applying address and indirect operators, right? So pointer ampersand 45 is not correct, right? It has to be a variable, right, that we are pointing to, right? Or pointer the address of miles plus 10, right? And in this case, this is correct, right? You can use the variable miles plus 10. This would result in the address of this, right? And if we're doing just miles here, it's okay, but if we add 10, this is not correct, right? So miles plus num is okay, right? But miles plus 10 is not okay, right? This will result in some kind of problem here, right? Okay, some taking addresses of pointers as constant. This is also a common error, right? Taking addresses of a reference argument, reference variable, or register variable. So look at through the common programming errors that might occur, right? And how it's being used here, so so that you get used to it, right? Also remember to use the how to use the new and delete operator, particularly for dynamic allocation of memory. If you forget the bracket, this could also cause problems, right? So okay, so keep note of that, right? So in summary, remember that every variable has a data type, address, and value, right? A pointer is a variable that is used to store the address of another variable. An array name is a pointer constant. Basically, an array is a pointer. In this case, access to an array element using a subscript can always be replaced with a pointer, because arrays are similar to a pointer. Arrays can be dynamically created as a program is executing, right? So you can allocate new address by using the new function, right? So arrays are passed to a function as an address, right? As opposed to a variable, we pass it by value. When a single dimensional array is passed to a function, the parameter declared for the function can be either an array declaration or a pointer declaration, right? So, and pointers can be incremented, decremented, compared, and also assigned, right? So keep that in mind, especially when you are dealing with pointers and references. All right, so this is the end of chapter 8. Next, I'll see you in chapter 9. So I'll see you next, right? See you. Bye.